Hey, all you cool cats and kittens. All right, so let's start on section 2. Sorry, Sarah's looking at me. That was from that tiger show.
That was disgusting.
Sarah's laughing at me. Okay, I'm sorry. I had to. You're home all day, no one to talk to. Okay. All right, so section 2 is about Eris, and hopefully, now she's trying to cook. All right, so hopefully you're reading along as we do this and really looking at the notes. So this one's about Aristotle, Galileo, and Newton. Aristotle, the dates are not important. They're just a time reference for you. He incorrectly thought that force is necessary to keep an object moving at a constant speed. And so when he thought this, that it held back progress for 2,000 years. He thought that, like, if you threw a ball, you had to keep hitting the ball to keep it going. Okay, so obviously that's not true. If we kick a ball or hit a ball, it just keeps going until something stops it. All right, then Galileo, he's definitely more recent, 1564 to 1642. He studied how gravity produces constant acceleration. That would be like something falling or something. So also that falling objects that were not subjected to friction or any other force would continue to move indefinitely. So he's saying that if you throw a ball or kick a ball, it's going to keep going until something stops it. And it's usually force, as in friction, okay, or somebody else or something like that. So things do keep moving until they're subjected to a force or friction that would make it stop. And then Newton is the next one we're going to talk about. This is 1642 to 1727. So you can see Galileo died when Newton was born. I don't think they had anything to do with that. But Newton, we're going to talk about all three of his laws. So these are going to be very important. You're going to have to know each law. So Newton's first law of motion states that the motion of an object does not change as long as the net force acting on the object is zero. Okay? So the motion of an object does not change as long as the net force acting on the object is zero. So if a ball is just sitting there on the ground, it's not going to move unless some kind of force acts on it. Either it gets kicked or hit or a dog hits it or something. It's not going to just get up and move away. Okay, some kind of force has to hit it. So unless an unbalanced force acts on it, that means that it's got some kind of net force, acts on it, the object at rest remains at rest, and an object in motion remains in motion with the same speed and direction. This is on my little joke or my meme on meme on Plus Portals about it's the guy in bed, and he says an object in rest stays at rest until an unbalanced force acts on it, basically. So again, if you have a ball, it's going to sit there until something acts on it. A ball could keep flying through the air until something acts on it, usually force or somebody else kicking it. The first law is also sometimes called the law of inertia. And inertia is the tendency of an object to resist a change in motion. So, in other words, an object at rest tends to stay at rest, and an object in motion tends to remain in motion with the same direction and speed. I kind of use this as an example, like if you're being lazy all day and you've been laying down watching TV and Netflix and all that, you're going to want to continue to do that. But if you've been doing stuff all day, it makes you kind of want to keep doing it. So this is kind of the same way. I mean, not obviously you're not going to do it 24 hours or something, but kind of the same way. The lazier you are, you're going to stay lazy that day. If you've been in motion doing things, you tend to keep doing the same thing. So that's the first law of inertia. The second law of Newton's motion. Newton also learned that the acceleration of an object depends upon its mass. Mass is the measure of inertia of an object and depends on the amount of matter an object contains. So, according to Newton's second law of motion, the acceleration of an object is equal to the net force acting on it divided by the object's mass. So let me get back to this in just a second. So it says how much it accelerates depends on its mass. Think about this. If I am going to throw a baseball into the air. I don't have to, I can easily do that. Okay, it might not go as far as some people, but I can do that. But if I'm trying to throw a bowling ball, I can't do that because the mass is so much greater than a baseball. So mass has to do with the acceleration. Okay, so think about a hippo. A hippo trying to get up and start running, or a cheetah getting up and starting to run. Think of that. Okay, hippos can kind of run fast, but a cheetah is definitely going to outrun them. All right, so according to Newton's second law of motion, the acceleration of an object is equal to the net force acting on it divided by the object's mass. So here's the formula. Acceleration equals net force divided by mass, or A equals F over M. Okay, so acceleration is going to be usually meters per second. Force is going to be in newtons, and then your mass is going to be in kilograms. Okay, so a acceleration is force divided by meters per second. So newtons divided by meters per second here. All right, so weight and mass. Weight is the force of gravity acting on an object, and mass is basically how much space it takes up, or the measure of inertia. So weight equals mass times gravity. So weight is equals mass times gravity. Mass is in kilograms. Gravity is meters per second squared, and that's going to equal a newton. Okay, so a newton is, weight is a force, actually. Weight is the force of gravity on an object. So a newton would be equal to kilograms times meters per second squared. Or you can write Newton's second law as this: force equals mass over acceleration. So force equals mass over acceleration is basically the same as acceleration equals force over mass. So you can use either of these formulas. Actually, you can use all three of these formulas. They're all the same formula. You can just use it to solve for different things. Okay? These three formulas you have to know. Mass is the measure of the inertia of an object, and weight is the measure of a force of gravity acting on the object. So I don't think these pages are right, but I think 367 is, but I don't think 674 is. So try to do those problems, and then I will have a worksheet for you to do on these probably the next day. All right, thanks.